Hey, we're back. Continue our lesson in section 11.3, where we are going to look at, given the solutions to a quadratic equation, how do we generate the original quadratic equation? So, given two solutions, or given, I should not say necessarily two, given the solution or solutions to a quadratic equation, derive the equation. Okay, so let's just take a look at the first example here. Suppose I'm giving, let's say in question 32, let's say I'm giving a solution that the solution to the quadratic equation is equal to 5. So if we have a quadratic equation that has a solution of 5, well, the one thing we should know right away is that this has to be a double solution, or one that repeats. So one thing we can say is that the two solutions, we can write this as x equals negative 5 and x equals negative 5. So how would we get this? This kind of harpens back to the work when we would factor a quadratic equation to get the solutions to it, which we've done some of this semester, but more of it was done back in Math 90. So what I'm going to do now is I'm going to go ahead and add 5 to both sides. I'll get x plus 5 equals 0, and I'll get x plus 5 equals 0. So now I'm going to take x plus 5 and x plus 5, and I'm going to multiply them together. And so I take what I get here, multiply these together, and when I FOIL it, it should give me an answer of x squared plus 10x plus 25 is equal to 0. So given a solution of negative 5, I go backwards to getting the original quadratic equation. So let's look at this in reverse to understand the relationship here. So if I take x squared plus 10x plus 25, the way I would factor this would be to write this as x plus 5 times x plus 5 and set it equal to 0. I would take each of these and set them equal to 0. And then I would subtract 5 from both sides to get x equals negative 5. So essentially, what I am doing in this process is doing the steps in the opposite direction. So it takes a little thinking and it takes a little getting used to, but as you see more and more of these examples, this should become clear, as well as engaging in some more practice. So this part's a little tricky, so hang on to your seatbelts. Let's see where we go with this. Let's take a look now, question 34, and let's see what we do with this one now. So 34, we have two solutions, negative 2 and negative 5. So what we're going to do now is, if these are two solutions, then we can say that x is equal to negative 2 and that x is equal to negative 5. So I'm going to get these equal to 0 now, so I'm going to add 2 to both sides, and here I'm going to add 5 to both sides. So here I'm going to have x plus 2 equal to 0 and x plus 5 equal to 0. So I'm going to take x plus 2 and x plus 5, and now I'm going to multiply them. When I do so, I should get the result of x squared plus 7x plus 10. Notice I'm not doing the FOILing work. I've showed you how to do the FOILing work. I showed you how to do the granny's box. I showed you a lot of things. I'm just going straight for the answer because I'm not focusing on this technique. I'm focusing on how you work from the solutions to get back to the original quadratic equation. Okay, let's take a look at a few of the problems to see how this applies. Let's see what one looks like when we use fractions in the problem. So let's go ahead and take a look at 36. We'll put 2 problems on this page and try to save paper. So we have 4, and then we have 2 over 3. So letting x equal 4 is not so bad, but setting x equal to 2 over 3 that's a little trickier. So let's see how we can handle that. So one thing I can do over here is to just subtract 4 from both sides, and I can get x minus 4 is equal to 0. But on this one here, what I'm going to do is I'm going to multiply everything through by 3. That's going to give me at first 3x is equal to 2, because the 3 is going to cancel this here. Now that I have that, I can subtract 2 from both sides, and now I'm going to have 3x minus 2 is equal to 0. So now I have x plus 4, and I have 3x minus 2. So now I'm going to put those two together, and I'm going to cross multiply them, or FOIL them, I should say. This is going to be 3x squared, negative 12x, should be negative 14x, and negative 4 times negative 2 should be plus 8. And there is my original quadratic equation that gives me these two roots, or gives me two answers here. Let's go ahead and try this with another problem that contains two fractions just to reinforce this skill a little better. So let's go ahead and try one that for 38. Technique is the same, but the work sometimes you have to do maybe just a little different. So the solutions are 1/2 and 1/3. So I got x equals 1/2. I have x equals 1/3. So what am I going to do here first? I'm going to multiply. So if you want to write this as separate steps, stop the tape here. Multiply by 2. This I'm going to multiply by 3. So here I'm going to have 2x is equal to 1. Over here I'm going to have 3x is equal to 1. Now I'll subtract 1 from both sides. So I have 2x minus 1 equal to 0. And here I'll have 3x minus 1 equal to 0. So now I'm going to take 2x minus 1 and 3x minus 1. And I'm going to multiply those together. So I've got 6x squared. Negative 1 times 3x will be negative 3x. Negative 2x times negative 1 will be, so it'll be negative 5x plus 1. And that's going to equal 0. And there is my original quadratic equation for that problem. So we have 6x squared minus 5x plus 1. Okay, that checks with what's in the book, and that's what I'm running with. Let's go ahead now and let's take a look at a question like 44. So in question 44, we have 3 radical 2, and then negative 3 radical 2. So these are the solutions that we obtain for the quadratic equation here. So I'm going to let x equal 3 radical 2, and I'll let x equal negative 3 radical 2. Okay. So one thing we can do is somehow we have to get this equal to 0. So now we're going to go ahead and let's see. Let's subtract, let's see, x minus 3 radical 2 equal to 0. Let's move this over the other side. And then x plus 3 radical 2 equal to 0. Well, let's see what happens when we FOIL these. And let's see what happens. So what you should notice here is that these numbers here are conjugates. So when we want to multiply x minus 3 radical 2 times x plus 3 radical 2, these numbers should come up pretty cleanly. So this is going to give us, let's see, x times x would be x squared. Then negative 3 radical 2 times positive 3 radical 2, well, it's going to be negative. 3 times 3 is 9. Radical 2 times radical 2 is 2, or it's going to simplify to x squared minus 18 is equal to 0. And that's how we obtain the solution to those questions here. I will show how to do the imaginary number work when we are in class, so you're not going to be able to finish all the homework in section 11.3 until I show those in class, but I want to make sure that everyone has a chance to preview these first and try these. Hopefully these won't be too difficult. That concludes our lesson for section 11.3. We'll come back with a lesson in the near future. Thank you.